describe motion, we need a frame. But the motion itself is independent of the frame. You don't need a frame to have motion. So to define a frame, we usually say, all right, this is the motion. This is t equals 0. They look like this. And let's say t equals 1. They look like this. And t equals 2, it looks like this. Let's give the time some unit, second. So to define a frame, we usually just say something's frame, which means the frame is moving with that thing. If we say triangle's frame, then the frame looks like this. It is centered at a triangle. So in a triangle's frame, the motion looks like this. Let's say this is 2 meters. This is 2. This is 2. Then this 2 on the x-axis is what we call x position. So you can say in a triangle's frame, the triangle is always at the origin. But for the block or the square, the x position is changing with time. Like 0, 1, 2. And it is always at 2, 2, 2, so you know it's 2. Okay? And for the y position, let's say this is 2, this is 0, and this is minus 2. Then you have 2, 0, minus 2. And if I wanted to plot the yt graph for the block in the triangle's frame, then first you put the frame on the triangle and make it move with the triangle. And you plot the y with time, 2, 0, minus 2. Make sure to include the unit and the number. Okay? If I ask you to do the thing in the plot frame, then the plot will always be at the origin, and the triangle is the one that's moving. Any question? Yeah, I think that concludes midterm. And make sure you know how to do dimensional analysis for all of these things. The first thing you learn in this class is position. And you know the dimension is length because you describe position as 2 meters, 3 meters away from something. Then the next thing you learn is velocity. You know it's going to be the change of velocity divided by the change of time. So it's going to be length divided by time. And you learn acceleration is the change of velocity. Velocity is the change of position. And acceleration is the change of velocity. So you will have to divide velocity by 1 more time. And you get length divided by time squared. And you write it as t to the power minus 2. Okay? And you learn F equals ma. So the dimension of force is the dimension of ma, which is mass times the dimension of acceleration you just got, which is like this. Alright? And you learn gravity will be gmn over r squared. So if you want the dimension of this g, you just divide the dimension of force with 2 mass and times 2 length. Force is this, gmn is this, so you get g is m l t to the minus 2 divided by 2m and l to the minus 2, and so on, t is still there. So you get this gravitational constant should have dimension of mass to the minus 1, L to the minus L to the 3, and T to the minus 2. Okay? And gravity near the surface of Earth is just mass times gravitational acceleration. If you compare F equals mg with F equals ma, you see that g is the acceleration. So the dimension of gravitational acceleration is a acceleration, which is length divided by time squared. Right? My suggestion is you go through all this by yourself at home, so you are familiar with this and you're prepared for everything. You know it's going to be on exam for sure. Alright. Some other force to learn is friction. Friction will be some coefficient times normal force. Kinetic give you kinetic, static give you, so maximum static friction give you, I'll just do one, that's it. Let's do kinetic. So force equals force. Friction and normal force are both force. So you know they have the same dimension and the dimension cancels, which give the coefficient of kinetic friction a 0 dimension. So we say the dimension of mu is 1, it is dimensionless, it's just a number. It's a ratio between the magnitude of normal force and the magnitude of kinetic friction. Okay? And you can put so a force from a spring will be proportional to the distance of the length. If you change the length of the spring, it will fight back. So it's proportional to that. There's a constant. You can do dimensional analysis and get that the dimension of this constant should be the dimension of force divided by a dimension of length. And if you look at the dimension of force, you see this will be mass divided by time squared. Okay? I think that's all the things we learned in main term. Yeah. Alright, so dimension analysis. Alright, let's do something for the final. So the first conserved quantity we learned for the final is energy. Energy is conserved, and if there's only kinetic energy, it should be 1/2 mv squared. If you want to change kinetic energy, you need to do work. And if you change kinetic energy, you see that this is the change of velocity squared, which will be 2 times acceleration times displacement. There's a dot product between them, is there? Should I do that? Yes, so you can check that it's the same. You did it by saying it should be ax times delta x plus ay times delta y. And you learn that this is basically the dot product between acceleration and displacement. You learn F equals ma, so you see that work should be the dot product between force and displacement, and that's the thing that changes kinetic energy. If you add up all the force and all the work done by the total force, what you get is the change of kinetic energy, not the change of energy. How do we get to energy? We separate the work into those done by non-conservative force, such as air resistance, and those done by conservative force, which is like gravity. So they add up to the change of kinetic energy. Because the work done by conservative force is really easy to calculate. For gravity, it's just the height difference. So you move it to the other side, which gives it a minus sign, and call that the change of potential energy. So this is how you get energy. And to change energy, you should only look at the work done by other things. You should not include the work done by gravity because it's already in the potential energy. Okay? Any questions so far?